All right. We are live. Sorry I'm late. I was sitting on the couch and lost track of time. All right. Which two resistors are in series with the load? So, in this particular circuit, let's open up the... Don't say. Let's open up a picture of the circuit. Pictures, DC circuits. Yeah, there it is. Oh, that's not what I want. I want to open up in Paint. Size 500. Okay. All right. So here, let's do this. All right. So, tracing out the current path. That is the key to working out a combination. The first key. There's a lot of keys. It's like a janitor's key ring. All right. So current leaves the battery, going like that. Then it travels. Here are the connection points. But 100% of the current goes through there, and it splits here and comes back together here, and 100% goes through there and goes back to the battery. So electricity can't get to the battery or leave the battery without going through R1 and R4. That means those two are in series. The same current that goes through R1 has to go through R4. So let's put this another way. If you there's a neat thing that you can do, and that is you can take symbols, and let's do a triangle. Let's fill it. Let's make it a filled triangle. All right. So you pick a resistor, and this is to tell if things are in parallel with each other. This is a trick. You pick a resistor, and you just pick a side of that resistor and put a symbol on that side, such as a triangle. And then you follow the wire, and everything it touches without crossing another component, you put that same symbol. And then, so without crossing another resistor or battery, these don't count. This is just a switch and a fuse. It might as well just be a wire. And then let's do green. So, and then you go to that same component, go to the other side, and put another symbol, and then follow that wire out. And now you have input that circle. You can use positive and negative, but that gets confusing when you already have like positive and negative, and then people are like, well, is this the positive side? No, it's not exactly that. So all these points with a triangle are electrically the same, and all of the points with the circle are electrically the same. So all the components with both of the symbols on them are in parallel with each other. Now, this doesn't tell you when things are in series, but it does tell you when things are in parallel. So let's do this again from R1. The first time I did it was with R2. So R1, let's start with this side. So we have circle, and then follow that out, so circle and circle. And then do triangles. From the other side, do a triangle. And then we have a battery, and put a triangle at the battery. That's it. That's all the components. So there's nothing with both symbols on them. So, and you can do this throughout the whole thing. You can do that same thing with R4, but it's not in parallel with anything either. R2 and R3 are in parallel. R1 and R4 are in series. Eventually, you should do enough circuits that you can just look at the circuit and be able to tell. So R1 and R4 are in series. This one, which two resistors are in parallel? R2 and R3 are in parallel. We just saw that. How many sets of parallel resistors exist in this circuit? So, looking at, that's not any bigger. So looking at this particular circuit, let's open that one up and do our trick. There it is. Alright. So, let's grab a symbol. Let's do a triangle. Make it red. Fill it in with red. Solid fill. Alright, let's grab R1. Put a triangle. Follow it down. Put a triangle. Follow it over. Put a triangle. Put a triangle. Now let's go to the other side with a circle. Let's put a circle, and a circle, and a circle. Alright, so R1 and R2 are in parallel with each other, and that's all we know so far. So let's change to green and keep the same triangles and circles. So R3 is what we're going to do. So we'll do the same thing. R3 is triangle, triangle, triangle. So we got that. And then on the other side, we're going to do circles of R3. So we have a circle, and a circle, and a circle. So all the things with two green symbols, R3 and R4, are in parallel. R1 and R2 are in parallel. But R1 and R3 aren't anything to each other right this second. Whenever you, let me move this over. Left green underneath it. Let's clear that out. So let's drag this over, make a quick copy. So R1 and R2 are going to combine together in parallel. And that's going to create its own leg. Let's delete. Okay, so R1, we're going to put comma, oh, it's white, comma 2, I don't like that pin size, and R3, comma 4. R1, 2, and 3, 4, because you'll combine these two together as if they were parallel and these two together as if they were parallel. Now you can see you just have a series circuit and you work it like a series circuit. All right. What is the total resistance of this circuit? So here's where we actually get into working it. And this is probably a more complex circuit. Oh, damn it. I hit all the wrong buttons there. Pictures, PC circuits, close this. This is probably a more advanced circuit than anything that would be on the test. Just to give you some idea. Of what you're going to be seeing. Alright, so first, you're going to combine your parallel resistors, right? Because there's nothing in series. Remember what I said. First, you check for series. That's a 2, not a S. And then you check for parallel. So, R1 and R3 are in parallel. They're both 20 ohm resistors. So remember, if you have identical 20 ohm identical resistors in parallel, you just divide the value of the resistor by the number of the resistors. So, 2 20 ohm resistors in parallel, they combine together. Let's to be a 10 ohm resistor. So, let's and that's going to be R1, comma 3 is 10 ohms. Now we have a 12 and a 36 ohm resistor. So let's open up our calculator and open parentheses, 12 reciprocal plus 36 reciprocal, close, and then reciprocal, 9. So those two combine together to be a 9 ohm resistor. And I will show my work for you. So these two, it's open parenthesis, 12 ohms to the power of -1 plus 36 ohms to the power of -1, close the parentheses, and then to the power of -1. You can also use product over sum, which would be the product of 12 and 36 over the sum of 12 plus 36. Those will both equal 9 ohms. So now, that would be R2, comma 4. So now we have two sets of resistors in series with each other and in parallel with each other. So this leg is going to be R1, 3, 5 is equal to 18.2, because that just adds together. And we can remove that resistor, or we combine these two resistors. Now 9 and 27, that is going to be 36. So let's R246 36 ohms, and that's going to delete that. All right, so that was just addition. That's all we did there, was add the resistors together. Feel free to click back if you needed to rewatch some of that. So now we have two resistors in parallel. Two resistors in parallel, and we can combine those together using our total equals, open parentheses, 18.2 to the negative first power plus 36 to the negative first power, and then do one more. So this is the reciprocal of 18.2 plus the reciprocal of 36, and then the reciprocal of that sum. And again, you can just replace these numbers in the product over sum formula and still get the answer. So let's do that in our calculator. Open parentheses, 18.2 plus 36, close parentheses, and one more time, 12.08. So our total equals 12.08. Did you see how I redrew it every step of the way? That is an important part of the process, is redrawing your circuit every step of the way. Okay. Got a lot of 123.2, because I guess you guys think you're supposed to just add everything together? Because that's clearly not it. I don't know where you thought it would be that straightforward. It hasn't been that straightforward in a long time. Alright. What is the total resistance of this circuit? Hey! It actually got bigger whenever I clicked it. Okay, so let us open up the image file. Right here. I'm actually going to leave it that size so I have more fighting room. So, our first step is to combine R2 and R3. So we have R total, R1, R2, and R3. And that's just 10 ohms, 20 ohms, and 30 ohms. Right now we're not caring about anything but resistance, but you know the rest of the drill. Now I do recommend making a squiggly line at the bottom here. And then, okay, we're going to combine R2 and R3. So our theoretical resistor, R2, 3, they're combined in parallel, 20 and 40. So come over to our I'll write it down. So it's open parentheses 20 to the negative first power plus 40 to the negative first power, and then one more to the negative first power. This is the reciprocal method. I'm going to harp on that so much. You're going to get tired of it. But this is the best method. So, clear. 20 plus 40, close parentheses, one more time, to the negative first power, 13.33. Oh, wait, I'm wrong. It's not 13.33 yet. These two are 13.33. Now you have, essentially, now you have the series circuit with 10 ohms and 13.33 ohms, giving you 23.33 ohms for your R total. Got some not sures, got some 23, got 8. Okay, we got 2 people who worked it out. Good job. Somebody stopped a little early. All right. Again, to those of you that just added them together, that's not it. That is not the way. All right, and now total resistance of this circuit. 20 divided by 3 is what? 6 1/3? 6.33, so it's 12.66 is the answer. I bet it's 13.33 and I've done my math wrong. Okay, so let's see. Let's open up that document. So, something to notice before you get started. These two are in parallel, these top two. So let's use our circles and triangles. So these two are in parallel. We can triangle, triangle, circle, 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 circle. Triangle would go over here again. And then let's do green, triangle, 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 and circle, circle, circle. Oh, that wasn't supposed to be green. All right. So 1 and 2 are in parallel, and 3 and 4 are in parallel separately. So without doing the whole chart, 1 and 2, it's going to be, and they're identical. Like 3 and 2 are identical resistors, and 1 and 4 are identical resistors. So we have a 10 and a 20 ohm resistor in parallel twice. So open parentheses, 10 to the negative 1 plus 20 to the negative 1, close parentheses, negative 1 one more time. And that's going to give us what number? Clear, 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 clear. Open parentheses, 1 plus 20 to negative 1, close parentheses, to negative 1, 6.66. So I was wrong. That's 6.667. And then you have two of them. So they're in series, so you'd add them together twice. Let's actually plus 6.667. Those of you that, I'm just going to times 2 on it. 13.33. That gives us that 13.33 answer. All right. And that finishes that one. That was a good little jog through there. All right. You guys, I really recommend doing this homework or going back and doing some of the old homework if you're not getting this. Feel free to ask me questions. Because this stuff is complex, and I do not believe it's a thing that you can just teach yourself offhand. All right, so let's finish this. And I haven't created a combination quiz for you guys. I will put that up later. There's not going to be one right now. All right, I'll see you guys later.